Hello, everyone, and thank you for joining our webinar today on the future of databases for AI agents. It seems like, I don't know if it's just me, but it seems like it's a good day. I think, what are we, the 487th of January, it feels at this point, a good day to do a webinar. So thank you for joining us. I'm Rob Reid, Technical Evangelist here at Cockroach Labs, and I'm joined by the one and only Spencer Kimball, our co-founder and CEO. Spencer, thank you so much for joining.
The pleasure, Rob, as always. I see that my headshot here needs some updating. It's kind of like false advertising. You expect to get this clean cut gentleman, and instead you get this.
I like it. Maybe we could cycle through the stages of hair growth, and then eventually you come online and we see you in your full glory. Well, thank you for joining. This is our second webinar together. The last one was fantastic, and I'm sure this one will be equally good. So today will be in the format of a fireside chat between Spencer and I, and we'll discuss what the future holds for databases in the advent and era of artificial intelligence and AI agents specifically. We'll cover things like how AI is redefining one of the hardest problems in computer science. We'll talk about how legacy infrastructure breaks under the load of the impact that will have as a result of artificial intelligence. We'll look at the requirements for AI data readiness. We'll also talk about how CockroachDB not only fits into this ecosystem, but thrives in it. And finally, we'll talk about the maturity curve, right from when you're kicking the tires of AI all the way through to fully autonomous AI agents. If you have any questions at any point, there's a Q&A function that you can find somewhere in the control panel. Feel free to ask us any questions you have at any point, and we'll try to address them as we can. There will be a section at the end for Q&A if we also have time. And there'll also be a survey right at the end. So if you have time, we'd appreciate your feedback. Without further ado, so Spencer, as you and I are only too familiar with, we solve a very hard problem of resilience, specifically in data. Is resilience still the hardest problem to solve, or with the advent of AI, is there a new hardest problem to solve?
That was a good question. I mean, the goalposts get pushed forward, I think, for all of the capabilities of operational databases as a consequence of this AI paradigm shift. It's saying that mission criticality is the hardest problem in data architectures. I mean, certainly you can make that argument. I would say that with things like developments on the geopolitical stage, the idea of mission criticality, as I said, sort of the goalposts are moving. It's quite a bit more layered now in terms of the complexity, right? People want to actually survive entire regional outages. That's not a big surprise. They want to survive vendor outages as well. So all of AWS gets taken down because of some zero-day exploit activated by a nation-state actor. That's actually what chief risk officers are concerned about. So, the problem of mission criticality isn't going away, but there's, when we look at our history, 11 years now building this database, mission criticality has been the number one reason people choose Cockroach. So I don't know if that's exactly going to change. But what's coming is something that's going to surprise people. It's really a revolutionary shift for operational databases, what they're required to survive. And it goes to the heart of the idea of resilience, in fact. And it's not necessarily the idea of surviving outages because of your infrastructure, your cloud, your private cloud, facilities going offline, fiber optic cables getting a backhoe through them and losing network connectivity, DNS messing up. That's probably the most common we see. Or zero-day exploits and that sort of thing. It's also about the resilience because of thundering herds, right, of AI agents, just AI, right, that's essentially accessing operational databases through APIs in a way that is very different from human activity. The right way to think about human activity, right, is it's been on this pretty incredible tear, an exponential growth. When you went from people on desktop computers and laptops, a very relatively small part of the human race at that point in time. Let's say it was 100 million people or a couple 100 million. Then all of a sudden, mobile devices started becoming common, and now almost everyone has one, multiple ones. And that, of course, led to real exponential growth in activity. And of course, at the same time, applications are becoming more complex. Like we have one customer that does delivery, food and so forth. every one of their deliveries can access the database and query or do a transaction that mutates the state up to 5,000 times. Right? That was unheard of in the days of yesteryear, right? In 1990, if that happened to your database, it would be all over if you had any scale. So what AI is going to do, which is fundamentally different, is it's going to move us from how many humans have a mobile device in their hands effectively. That's where all the scale is coming from now to no natural limit on proliferation. So you're going to have, order of 10 billion humans working right now. That's going to go to, it isn't there yet, but it'll go to order 10 billion agents. Then it'll go to 100 billion agents, then a trillion agents. And God knows how far it'll go beyond that, right? But, the sky's the limit. So that is going to be coupled with very different patterns of interacting with APIs in the database. The UI is a goner, right? The UI is a very slow way to interact with backends, right?
It's a very
Plus
human
with
way
a
to interact
human,
with backends. Yeah.
right? I mean, you're talking about at the fastest, like a 200 millisecond between interactions, probably more like 2 to 10 seconds if someone's very busy on there. And those follow predictable patterns, right? Humans are awake at certain times in certain regions and so forth. So you get like, you can really predict, and they're not working on weekends. And so some of that's going to change, right? And change pretty dramatically. The interesting thing about agents is we're already seeing it. I mean, if you're paying attention, it's amazing. They always decide to write programs to get things done. Right. And so what's going to happen is that the interaction with backends, instead of being through a user interface, often on mobile device, it's going to be an agent autonomously constructing a Python application, for example, that is, instead of doing, several requests every minute or, let's say 10 requests a minute, something like that, it could potentially do 5,000 a second, right? Because it's processing lots of lines of things. If it runs into some kind of error and is trying to correct itself, it can create all these recursive, sub-spawning of additional agent runs or new queries and so forth. And you can even easily see how with this incredible rate of things happening and you do something, then the agents will check it and verify things. So like if you don't have a consistent database in this world, it's over. In fact, I would say that agents spell the absolute death of eventual consistency. And interestingly, many applications out there are running on things like Cassandra or older versions of MongoDB where the transactions are not activated. And this is a significant problem. Or DynamoDB, right? And it's like, well, eventual consistency, users take some time and this thing updates fast enough and they don't get it right. Then, people have been waving their hands about this for a long time and it pretty much works, right? I think we're entering a revolutionary upheaval in terms of what an agent needs to succeed, how fast it's doing things, how it reacts when it doesn't get the right answer, and how those failures can cascade. And ultimately, we're talking about, somewhere between 10 to 1,000 times more queries and transactions on back-end databases. So, we think about the hardest problem. I think most companies in the world right now that have an even semi-popular product or API, and first of all, their applications and the user interfaces are going to be completely, up for grabs in terms of, whether you're just working with an agent, a chatbot or whatever, or it's generating UIs on the fly. We'll see where all that goes. But the reality is if you're on legacy infrastructure, and of any sort, you don't have a truly cloud native, elastically scalable infrastructure. It's not just the database, it's the many layers above. Then you are going to run at 100 miles an hour into a brick wall when this stuff's coming. Unless you turn off access that isn't, and even that will probably be difficult. There'll be many ways around because people will want agents to do things on their behalf. Third parties will create agents to access your APIs on users' behalf, right? The era of applications doing things for users or users using applications is over, right? Users, customers, and human beings are going to be interacting with agents that are, doing things for them with a much higher level of quality and at machine speed. So we're moving into an era where fundamentally infrastructure has to be rethought. And the hardest problem in this, you could say it's resilience and surviving these success disasters and scaling up with the activity that's coming. It's a tsunami, right? You want to get on top of it, not get washed under it. But the hardest problem might be something that's sort of a corollary, which is, well, how much is this going to cost me?
Yeah.
right? I
Yeah.
mean, whoa, if you're talking about, hey, we're going to need in 3 years 100 times more queries across our products and services, you might say, well, okay, I can use Spanner or Cockroach or something like that, or even Cassandra if I somehow can get around the eventual consistency problems. But that's going to be 10 to 100 times more expensive in 3 years. Like database is already pretty expensive. So what does that mean? And that's the fundamental hard problem. And it's where we're putting a huge amount of our attention now. Like our belief is that with a distributed architecture, when that's what you turn your innovation lens on, there's incredible opportunities to keep the cost very sublinear as the scale goes up and to push really hard. I mean, my goal for Cockroach DB is to be the least expensive database at scale on the market. And if you're not that, you're going to lose. This is going to be no incumbent's going to survive. Oracle, they're goners, right? It's
Simply because of
impossible
the
because
ease
yeah,
of
people have
scale
been
and the cost of scaling.
right. Exactly. I mean, if the least expensive database at scale is going to win the whole market. That's my prediction. I feel like that's an ineluctable logic because the costs are going to become tremendous here.
And that's inescapable in your mind. The enormous scale that AI agents are going to have on infrastructure. Like we had to re-engineer the web when mobiles came along because of the sudden jump in scale when everyone came online. Are we going to have to re-architect the web and everything that connects to it as a result of this next leap? And it sounds like this next leap is going to be a lot bigger a leap than the previous.
It's going to happen faster. So that's going to compound the difficulty and the friction. Yeah, this is just an acute pain point coming. Everything will need to be rewritten. And the interesting thing is many of our big customers are sitting on top of a mountain really of legacy applications. In some cases, I mean, we've seen examples of this is kind of blow people's minds. 16 million lines of hand-coded machine like assembly on mainframe. And nobody can touch it. It's very valuable though. Right? A lot of that company's data and processing is still tied up intimately with that use case. And so the interesting thing is, how do you tackle that mountain? How do we even move the things that are, that are actively being developed and we understand today in an enterprise organization? And again, the answer is AI. It shouldn't surprise anyone. The ability to modernize has never been greater, and that is going to rapidly improve rapidly, right? And so really the goal for operational databases in that world is to support it all without becoming ruinously expensive. So yeah, there's everything's going to be rewritten. It can be rewritten for the first time, and that's why all of the incumbents are going to either evolve rapidly or they're going to die. Oracle's cash cow with their flagship database, which is most of the enterprises in the global 2000, that for the first time is truly, under a black cloud. Its survival is absolutely in question because it's just not a scalable architecture, and it's worked, and they have many licenses out there that are in production, and those things are very hard to move. Well, all those dynamics are changing; they have to change, right? And any business that doesn't push in that direction, figure out how to modernize, is going to be in bad shape compared to competitors that do, because everything can be changed now, right? So you either grab the bull by the horns and ride it, right, or you're going to get trampled under it, and that's like it's existential, really. And I don't want to appear too alarmist, but when you watch some of these AI agents, especially when you can kind of see their little individual steps, like Claude Code, wow, the amount of things that it's doing and the quality of it, it's starting to be staggering just in the last 3 months. And so extend that across the board for every kind of role and application, and how do you optimize a human being's life? Like all these things are going to become, the adoption rate is going to be faster than what we've seen in past cycles, I think, by quite a bit, just because look at what happened with OpenAI. right? How many
Yeah.
customers did they get? How quickly? I mean, they just broke the whole mold. How quickly did they get to a million customers? It's a minuscule amount of time compared to the next closest, right? Which was orders of magnitude more time to get to a million customers. Why? Because this stuff is so useful. Right? Everyone can see it. It's just like a million times better in some ways, right? Oh, it was imperfect. Look how much better it's gotten, and how quickly that's happened, right? I'd say just like
Humans aren't known for being perfect either, are we?
we're certainly not. And I think there's a very real possibility that, you know, I was somewhat resistant to this because it wasn't comfortable, but there's a real possibility that AI will become a lot more perfect than even the best humans at tasks like software engineering. And so it's kind of like nobody wants to use punch cards, right? Nobody wants to not use a compiler anymore. And we kind of gave up all of the incredible expertise that people had in managing registers by hand and so forth, and just let the compiler do it. Man, when people saw that happening, they were like, "Oh, this is compiler slop. Look at this. Look how unwasteful it is, right?" But not many people do hand-coded assembly unless it's the most important thing in your most critical inner loop, right? But that's what's going to happen with execution for human beings, and it's kind of sad in a way, but we're going to have to move up a level, right, and really provide the intention and the agency and the vision, and that even is going to be increasingly informed by AI. So, where does that leave us as humans? Well, you know what? Actually, the way I see it is we're all just going to be creators, right? And that's the mindset that we have to adopt, and that's well how we'll be, I think, happy and successful.
Thank you, Spencer. As you were talking there, we had a question come in on the Q&A. So we'll address that now. The question is, nearly every data infrastructure vendor under the sun is currently saying that their database or product is the right fit for the agentic future. How do we think about finding signal in all of this noise that everyone's making?
That's a great question. Certainly, you'd be, I think it would be a mistake for any vendor not to figure out their AI story and to promulgate it to the best of their ability. So, yeah, it's just this is a paradigm shift. So everyone's going to figure out how they fit into this. I think that, the real answer to this has got to be in how quickly can you experiment with things and have an agile mindset and consider uh, you know through empirical evidence how these different solutions stack up against your workloads and the problems that your firm has decided are the most important to solve. So that could be around, hey, we really have to work around EU regulators. We're a critical industry. We're a bank. And so, part of that sets a whole bunch of requirements. And so you're going to see, well, okay, what actually is meeting these requirements and what's their credibility? What are their other customers? What's the leader in my product category using? These are all sort of good questions, but I think nothing's better than saying, you know what, we can try them all out now in a way we never could before because we can move extremely quickly in doing a POC, in asking an agent to go out and do like our own POC for us, right? Like these things are all possible now. I think empirical data is the real judge, and then ultimately it comes down to if the product, for example, you're building your whole data architecture, you're rebuilding it, if a particular component in it meets the requirements, then you want to say, okay, well, what's this going to cost us and what's the direction and where's their focus on innovation? Because I think what people have to keep in mind here to this earlier point, of course, I'll keep banging this drum, it's just scale. Like I'll say this, like across our entire customer base at Cockroach, with Cockroach DB, probably no more than 20% of our customers or our workloads truly have a scalability problem. Most people have chosen Cockroach because they really want the thing to stay up, especially for a regional outage. That's a very hard problem. So what are the latencies and things? And Cockroach is good at that. We've got a lot of experience, got a lot of customers doing that. And that can even be a small use case, like 3-node Cockroach cluster or 5 nodes or something like that. But you're spreading them across regions, and that's a great pattern. But I think there's very few of our workloads right now that aren't going to actually start to say, oh my God, like like this is not a problem that even if I didn't care about resilience, I could put on to a Postgres instance. 64 vCPUs, never going to cut it. I need 300 vCPUs. I need 1,000 vCPUs. Right? Like you've got to think whatever you're currently fitting into, however many vCPUs, how big a scaled up vertical box, uh, you know, if that has to go to 100x in 5 years, what's going to happen? Right. And that's kind of, I think that is that when Elon Musk recently said something about a tsunami. I kind of like that just as a mental image. But like, that's a significant risk on the horizon, right? You got to get to high ground. You got to figure out like, do I have a boat I can go into it? Whatever it is, like this is not something where you sit idly by, right? And that's the thought experiment that has to be run. Like what happens when we get to 10 to 100x in a short order? Like I think what we see is that most enterprises have workloads that don't need Cockroach for scale, and yet those workloads are some of them are very small, right, and fractional, but many of them are like fairly scaled up on a vertically scaled architecture, right? They might have 2x or 3x headroom. Like, maybe we can get more vCPUs. We can move this thing to a bigger instance type or whatever it is. But like 10x, that's where things really start breaking. And 100x is just kind of like, well, oh my God, how do you even do that?
Well,
Uh,
that's really implementing infrastructure and architectural decisions fundamentally. If you're not ready for it, you it's it's so fundamental a problem that without the without the right tools in place, let's say you're running a monolithic legacy database. Previously, you might have seen a trend towards busier product growth, business growth, and you would have taken your instance down, you'd have opened it up, you'd have added more RAM, CPU, whatever you needed to do, and closed it back down again. Do you now, as a business, have to decide, well, I need to 100x this box right now and take the hit going forward in the event that we do hit 100 scale? Or do I have to do it in increments? And if so, how many increments? And during that period, how much downtime is my application facing? And that's why, for me, it's not just a case of scale, but can you scale enormously whilst offering serializable isolation? Because when you're running agents that are inherently non-deterministic, like humans, they'll at least help them hallucinate with the right data. Because if they're hallucinating anyway and they're using wrong data or out of date data, it's going to be an absolute mess. And you mentioned earlier about the stampeding herd. We saw we see success disasters in the industry all the time. Think about the Taylor Swift Eras tour. I know we've referred to that a few times. That was a stampede of success. That wasn't 100 million agents waiting to scalp the Taylor Swift market and all continually retrying because the application would never come up again. As soon as it does, it's taken back down again by the load. So it sounds like an enormous problem to solve, all whilst being resilient.
I think the key is elastic scalability, right? And where that doesn't require downtime or lock tables or anything like that. It's just, hey, add nodes in here. There's a lot of interesting things you can do when you have a truly distributed architecture, and especially if you're using the public cloud where these resources are very liquid in terms of not just the fact that you can get more, but how quickly you can get them and then how quickly you can give them up. So, there's an interesting architecture that some of our customers have started to adopt with Cockroach, which is, well, there's actually when you use EBS, which is their network attached storage, there are some pretty interesting like optimum price points in terms of like what's the cost per IOP, right? It's not necessarily like even across the distribution of different, hey, here's the IOPS budget, here's the EBS type, and what you can do is you can actually have lots of EBS volumes attached to one Cockroach node, and then you can really scale up your Cockroach nodes and then just reassign these volumes. So you start to create more independence between compute and storage, and that's a way that you can actually scale up and scale down in minutes and not move any data around. So it's very inexpensive, but you're decoupling that compute and data. So that's an interesting direction. But listen, the reality is not everyone's going to move all of their legacy and use cases to a whole new data architecture at once. That's totally impractical, no matter if the AI was 100 times better than it is today, which maybe it will be by the end of the year. But like the reality is you want to you want to move quickly with experimentation, get the empirical data, build the trust, get the understanding, and then you're kind of moving from exploratory to an acute pain point, and then you go from the most acute pain point, in a sort of priority order out from there, and eventually you're saying you're going to sunset the old model, and every other application needs to move. That can, I mean, there's all the legacy stuff. That's a whole nother project, but it just depends on what kind of organization and how much of that they have. But I think there's smart ways to take this in steps, and then whatever infrastructure you use, it's just very important that once you move to this stuff, you really do have that horizon. You certainly don't pay for 100x if you don't need it. You want to pay for exactly what you need, right? But you want to be able to say, hey, if we go from where we are currently, 1x, let's say, and we need to go to 5x, that is something that isn't going to require downtime, and then to go from 5x to 10x into 20x into 50x. All these things are really just a matter of setting a configuration, and hopefully as time goes by, as you're spending more because you have more instances attached into this distributed data architecture that you're building, the more recent versions of all of those pieces of software, all those vendors that are contributing, are finding the right point on the sort of the total cost of ownership optimization curve going forward. Like if people aren't working on that, if your vendors aren't working on that, I'm sure they're very happy. Anyone that can see the writing on the wall here of like, wow, we're gonna all this data coming. This means a lot more, licenses, or a lot more, total data under management or memory required, or whatever it is that they're selling or pricing based on. It's a very short-term sort of thinking, because this problem is so big and so problematic for customers that any vendor that's not working to lower their costs dramatically, we're talking about order of magnitude more, if possible, like is set up for failure, right? People will flee anything like that as this tsunami hits.
So rather than more revenue, it'll be fewer customers.
Well, ultimately there's more revenue, because think about all of the expansion potential, right? How many use cases or workloads that currently people haven't really had any reason to move because they're working, right?
Yeah.
Fine. But like what happens when everyone starts to feel that incredibly different sort of data pressure that's going to come from AI instead of humans interacting with backends? In that case, you start to think about everything moving. So that's why I say like the vendors that figure out the best TCO at scale are going to be runaway winners in the market. And that applies to operational databases, analytical databases, search engines like TurboPuffer and Elastic and that sort of thing, like queuing systems, the Confluence of the world, even the purveyors of GPUs, and right, Cloud 2.0 is going to be, I think, a lot more fluid than Cloud 1.0 in terms of, okay, we've got these big three hyperscalers, most everyone uses them. Cloud 2.0, hey, we almost certainly will have orbital data centers, and it's basically where's the inference cheapest, and where the data architecture per sort of like transaction or query cheapest. Like there's that, just because of the incredible scale up that's coming.
Yeah. Thank you. Let's move on to another topic then. So from what I've seen, what I've read, and what I've experienced firsthand, legacy infrastructure is already pretty broken. For those who on the call who may have read our State of Resilience report, you'll see that legacy infrastructure is in a pretty bad state, and DORA, the Digital Operational Resilience Act, is, in my mind, proof that what we have currently working against legacy systems, etc., isn't doing enough to protect modern day workloads. And I'm guessing agents aren't about to make anything easier, because most things were designed for human paced demand. So we recently conducted a survey. We'll be releasing it later this week. And it's a step beyond the state of resilience. This is the state of AI for data. And 83% of the people we spoke to said that their data or AI would exceed their data infrastructure within 12 to 18 months. Spencer, what would your advice be to one of those companies that's running legacy technology but trying to modernize to keep up with the AI rush and manage the risks of migration to a more modern technology?
Yeah, it's a great question. I mean, the timing on that is maybe even more aggressive than what I've been saying so far in this webinar. Uh, and that's a pretty wide-ranging survey across the industry. So definitely, I think the realization of these this risk is pretty widespread, which is good to see. But I'll say that even before AI started working, so to speak, legacy infrastructure was breaking pretty definitively. And I think there's lots of stressors on it. Certainly, just the organic increase in scale pre-AI was enough to definitely start pushing certain use cases over the limits of a monolithic architecture. We have quite a few customers that are at petabyte scale. That's typically the biggest sports betting, the biggest bank, the biggest whatever, right? And that feels like that problem is going to democratize, right? But then there's geopolitical stressors. I think we're seeing a lot of that. You mentioned that we're on the 400th plus day of January. I think one of the things that interestingly came up at Davos a lot. I wasn't there, but someone informed me who was there that Cockroach came up quite a bit. Because people are very worried about data sovereignty in a way that before it was kind of, more like an European concern, right? They're a little bit more concerned about where the data goes and where it can be shared. And I think that's appropriate. But I think now that concern is intensifying, right, for lots of reasons. And so legacy infrastructure doesn't have much to say at all about that. What Dora is saying is that you have to have a plan, right? You can't just like I think the industry norm up until recently has been, well, get it into the cloud. If it works and your users aren't complaining that much, great. We're just trying to get off the old client server model in the last 20 years, and things kind of move at the rate that they move. I think that there's with Dora and GDPR as well. The European model is to not be entirely prescriptive, but to say, here are the problems that you need to be worried about, and you need to have some kind of plan for them, right? And so what happens is the state of the art today becomes more the requirement tomorrow, right? But it's all not overly prescriptive, as I was saying. So Dora's saying all of your third-party IT vendors need to have some kind of replacement plan. And that's a tremendous lift, actually, because it's very tempting, and most small companies just do this immediately, and it's the right choice, right? But it's tempting to put all your eggs in one cloud basket, one hyperscaler basket, because they create these rich ecosystems, and they want that too, of course, right?
Yeah.
But they have all these vendors, and they've got all these integrations, and you get one bill, and as one throat to choke, as people like to say, and that makes sense when you're smaller scale, right? But when you have a critical application, you've got, million to, 10 million, 100 million users, what the EU is saying now, and I think increasingly will kind of permeate worldwide, is you cannot just rely on any single third-party vendor. There's always got to be if this fails, here's what the alternative is, and here's how long it takes to stand up. And so that's just not what legacy infrastructure had in mind. It's not even what most of the cloud vendors had in mind, right? Because it's not the sort of walled garden that they like to see in terms of
It's
like
not in their best interest. It's in their best interest to keep everyone on their cloud.
absolutely.
Yeah.
But they're starting to look different, right? I mean, there was a
Yes.
recent announcement with AWS and GCP providing a very easy way to link the two clouds that you would have had to do quite manually with a third party like Equinix before. So that's a great development. There's also some forgiving, depending on the legal jurisdiction, of cloud egress costs.
Yep.
I expect to see more of that, because the reality is that AI agents that are helping to build infrastructures and architectures and applications going forward, these kinds of things are much more solvable, right? So again, it's kind of like what's the state of the art today, in a year, becomes sort of standard operating procedure. And it is because the costs come down, the complexity, the actual dollars and cents, and you don't need to hire a whole extremely experienced team to do it. Like you can't even hire a system integrator to do these things well enough, honestly. But increasingly, everyone can participate in those kinds of architectures, and the cost comes way down. And so that's the sort of cusp that we're currently on. I think it's exciting, but I will say that the businesses that aren't really already engaged in thinking about this transition are going to have to be soon, right? Whether it's regulators coming after you, or your own legal team considering the liabilities, or like just failures that I think are going to become more common and more costly. You mentioned before our State of the Resilience report. Oof, the costs of downtime, they're eye-watering. Like, and this
And
was
the amount of downtime that people are suffering. Of the 1,000 people we spoke to, 1,000 people were affected. It's there's I don't think there's many companies in the world using legacy technologies who are weathering outages. It's just simply not feasible.
And there's still outages with Cockroach, right? It's a question of kind of where you are on the curve, right? Like there's a way to minimize them, minimize the cost, minimize the duration, minimize the frequency. And again, like what I think is the beacon of light here that helps is that AI is not just the new stressor that's going to make things immeasurably more difficult. It's also the help required, the helping hand required, to navigate this coming transition without having extraordinary costs in an organization. If you think about, let's say, if you've got 1,000 use cases that are still written and written in COBOL, let's say, running on
Yeah,
mainframes, right?
yeah,
The cost of trying to get Accenture in to upgrade those has always been too high to make it a positive ROI, right? But Accenture with AI, or your own teams with AI, this is the threshold lowers, and I
yeah.
think dramatically. And so we can, it's not impossible to overcome these these challenges, and it opens up an opportunity to move very quickly, and I think essentially build much better products, and things that you may have had on the drawing board that seemed pie in the sky, and maybe we'll get to that in some future. There's a chance to really start to engage with those more interesting activities and ideas, make your customers' lives better, and obviously, I think make all of our lives better. It's much more interesting to work on those pie in the sky ideas than to just keep toiling and keeping our head above water because of all the noise that just comes with the normal organic growth.
Tending to your COBOL applications. Yep. We had another question. It came a few minutes ago. Apologies, I haven't got to it yet. I've built a few AI applications with MCP to a MySQL and Postgres database, or direct to RAG. How does Cockroach DB fit into this? So I'll do my best to address this. Cockroach DB will look and feel just like Postgres to you. So any MCP servers or tools that you're currently using for Postgres will 9 times out of 10 be absolutely fine running it against Cockroach. We are building our own MCP servers for our managed service offering, but for the most part, ultimately, vectors are stored in Cockroach DB with a powerful vector index that distributes data across or horizontally for scalability and resilience. So I would imagine that using it in the same way that you've been doing against Postgres would be no problem. Anything you want to add there, Spencer?
Yeah, that was great. Thank you, Rob.
Okay, so let's move on to data readiness then. We've got about 5 minutes left, so we'll go through this. I don't know how much we'll get done, but we'll go. I don't have a hard stop. So, in order for a data architecture to not only, or just an architecture in general, to not only survive but thrive in the agentic world, what does that architecture have to look like? Like, and also following up from that, we've talked about scale and the amount of scale that agentic AI is going to have on all of our systems and databases. How much of this AI initiated scale demand is theoretical or hype versus actually seen in the wild?
Well, it is mostly theoretical. I think there's a very interesting curve of data under management growth, and it's historically extremely consistent. It's a bit more than 10x every 10 years. And there's, I think, an expectation here when you look at how much human activity or human traffic, human generated traffic has been increasing. It definitely has ridden an exponential, but that exponential is petering out. It's almost like a sigmoidal curve. Traditionally, what's happened, whether it was the advent of the cloud or the advent of mobile applications, whatever, is you have these layered sigmoidals, and in aggregate, they form a fairly smooth exponential, and it seems very clear that AI is going to be the thing that takes our incredible global traffic that we currently see and keeps it on a very steep exponential. Right, we're kind of everyone, I think, right now is feeling that rate of change more viscerally than I think humans have in the past. But it still remains somewhat theoretical. And the reason is that the total amount of AI generated traffic right now, in terms of agents, building Python scripts and then running them against data sources and things, it's still relatively small. And the question is just like, well, how fast is it going to scale? Because when it does equal human traffic, right? Let's say it's a small fraction of human traffic on January 27th, 2026. But at that point where it's about equal to human traffic, and so we've got kind of twice the global traffic that we would have had if AI hadn't been invented, it's going to be going vertical, right? So it's theoretical, but like, one way I think that you might convince yourself of what's coming is to use your favorite AI, put it into thinking mode, and ask it about the implications of AI agents for operational databases. I think you'll be interested to hear what it has to say, right? Like, and you can evaluate those posited uh, claims for yourself, but it's nice to have to check your thinking across these different things and get some ideas of what this is going to mean for your organization. I think that when some of the implications that I'm paying attention to, I mentioned before, like the death of eventual consistency. I think everyone's going to have to move to serializable, very strong isolation, and globally too, because anything that is a crack in this is either going to create a lot of cascading failures. That's sort of the best case, or actually be an attack, vector. So it's like some of your surface area that actually could mean that things are double booked and money's extracted twice and things. They've already had examples of that, but the cyber threat from AI makes chinks in your database armor, like eventual consistency, considerably more threatening. Certainly just the transaction density is incredible here. Where humans are looking at 1 to 5 per minute on average, let's say, an agent could be 10 to 100 per second. So you're talking about unbelievable increase in transaction density. And there's also how much more metadata you have to keep, right? Nobody wants to see hallucinations. It's not just the hard, cold facts of your system of record. That's going to be augmented with a continuous sort of audit log of all the provenance of various things. And so there's you can expect a lot more mutation happening, not just because the systems are busier because of agents and so forth, but because you're actually creating a lot more artifacts as a consequence. There's also a really interesting problem with relational databases, right? SQL can go out of control. Who hasn't had some application developer create a SQL query that ran off the rails, right? And does a table scan or whatever. And
Especially ORMs.
yeah, right. So LLMs, this is, when you think about applications and the way that things typically interact with your database as a consequence of a user hitting a UI button, these things are known and they're hard coded. You might have a new release of your application that introduced a defect that made the wrong call on the database, or the database had some sort of problem and chose the wrong query plan or whatever. It's going to get much, much worse in terms of complexity because these things are going to be dynamically generated by LLMs in many cases. And boy, you need to have an incredibly good resource allocation model within all of your data architecture, because these things are going to surprise you in terms of how awful they are in some cases. And there's the only protection against them is to like eliminate the whole class of problems where everything's based on sort of a token bucket type system. And those have to be very sophisticated, or else they end up making your systems very slow. And then there's, we had this like very predictable resource usage cycles in the past. Now you're talking about lots of autonomous bursty behavior, extremely unpredictable. So like the idea of, pre-planned maintenance windows and upgrade cycles and things. Well, you need your data architecture to run at peak load, no matter what you're doing, no matter what kind of upgrade you're doing, repaving your nodes, um, you know, let's say building additional indexes, changing your data model, running multiple versions of your application, all these things. There's no the idea of managing a transition with downtime becomes considerably more costly than it has been in the past.
So no downtime, no maintenance windows, always on becomes incredibly important because
Absolutely.
you're going to disrupt not only your human users, but hundreds of millions of AI users at the same time. We've had a few more questions. I appreciate that we've got right to the end of our time. I
Oh,
think
well,
we'll probably,
Rob, I would say one interesting thing about that. AI
yeah,
agents will move real quickly. Like I think the beauty of human customers and organizations, like if you're a B2B, you're the other businesses that use you, there's like a lot of inertia, right? People have muscle memory. Organizations have the aggregate of that individual muscle memory, and it becomes institutional, sort of capture. The AI agents, if there's an equivalent way to get the information and your system's failing, we'll just go use another mechanism and it will be frictionless. And the end user will be happy about that. But eventually the AI will learn that another system is better. So like that presents significant concerns, right? Like the idea of brand loyalty, which I think is very powerful in the age of AI. It only goes so far, also because of the age of AI. So it's something like it's hard to rest on the laurels of that of like that sort of that very important dynamic of people just sticking to what they know and being grateful for that provider and giving them some time as their system might need a reset or whatever it is.
because if you're so just so I understand this, because although your brand loyalty might be with a specific provider, your agent might itself have reprogrammed to talk to a different provider based on its previous experiences with another.
Oh, yeah. I mean, like, let's say that you're a big user of AWS and, your whole architecture is running on it. And increasingly, agents are helping you with the SRE work and the software development work and so forth. And you have a big outage. I would be shocked if the agent isn't saying, "Well, why don't you move to running across clouds?" Or like I've not analyzed the cost competitiveness of AWS versus GCP, and the instance type on GCP that would give you the same thing is 30% less expensive. Would you like me to move it? Right? That's a pretty terrible thing when what you're when you've become somewhat sclerotic. I'm not saying AWS is at all. It's a very good company. But like if your company is somewhat sclerotic in attending to concerns and outages of the end user, the switching costs are going down. And it doesn't matter if it's just like, if it's a huge enterprise uh, B2B type of product that's being consumed, or it's an individual end user and they're just trying to manage their schedule or their bank account or whatever. Right? The complexity of, for example, transferring your account from one big bank to another big bank definitely keeps a lot of users loyal on that one bank. They know your interface, whatever. What happens when the interface isn't there anymore? What happens when like the movement of your bank account balance and all your records from one provider to another is done by the AI and it's simple. And there's all these trust models. I'm not saying all this is going to happen next year, but like that dynamic is going to become far more pressing. Switching costs are going down across the board.
So you could be banking with one bank one day, and it becomes more effective, cost effective, better experience to bank with another bank the next day. You can switch over and then
Yeah,
perhaps
all
back
your
again later
automatic
on.
bill pays, all of your like history will be nicely captured in there. You wouldn't be like, well, I'm so used to my mobile app and how it works. I don't want to go learn something new. Instead, I think these UIs will be superseded by more of a personal assistant like that. I think that's on the near horizon.
Yeah. Thank you. So we'll take one question while we're on the call. To those of you whose questions we haven't answered, we will get to them. We'll share our slides afterwards, probably tomorrow or maybe the next day, along with any answers that we've missed. So the question we'll take is, if you could go back to your first years of college, knowing what you know now about agentic AI, how would you pivot your major, coursework, or career path?
That's a good question. I mean, I probably would have done the same thing if I was truly back in 1992, because it made sense then. But if you're asking what would I do in 2026, it would probably not. Well, I don't want to say that. I think understanding how the whole technology stack works is not wasted time. It's kind of like studying Latin or learning philosophy. These things they're valuable in their own right. So I think truly becoming an expert in how things were built, like when you take computer science, you learn all kinds of historical, details and things, and that sort of informs the state of the art. I think there's going to be plenty of interesting work here, but honestly, what I might kind of move a little bit more to the most exciting part of the physical world. I have an incredible interest in space, so that feels like truly the next frontier, so to speak. That the high frontier, as they call it. I think space would be, learning truly specializing in something that would get me up into space would probably be what would captivate me where computer programming did back in 1992.
Very cool. Thank you. So we've run out of time. The one thing I'd love to leave you with before we head off is Spencer's a link to Spencer's Forbes article. Spencer, do you want to just give us a really quick overview of what you discuss in the Forbes article? Because I think it's paved
You
the
should get
way.
that, Rob, because I think honestly, what I've talked about in this webinar is pretty much what I tried to capture in the Forbes article. I think I might have been a little more emphatic in this webinar, but is there something that you recall from the article that that we didn't cover?
I don't think so. There were a couple of main other topics about Cockroach DB fitting into the agentic era, especially to the question that we received right at the start. And finally, the process of going from no AI to through the natural steps you might take when you're adopting AI. So, for example, perhaps adding semantic similarity search or recommendations to your product, which historically has been a really big lift. You've had to invest in specialized tools in order to provide that level of creativeness from your applications. Next comes natural language processing, which is where we get into the chat bots, but also allowing an LLM, given the context of your perhaps database schema or application at large, access to make its own decisions about it, make design SQL queries and execute them. So there's also that, but then finally to agentic AI. How do people go from kicking the tires with the tools that are available and the concepts of AI all the way through to automating swathes of their business, be it internally or B2B, as you say. So I think that's what perhaps we would have covered if we got more time. But on the subject of the journey from nothing to everything, there will be a demo coming out very soon on that where we'll cover that. But before we head off, is there anything else you'd like to add, Spencer?
Well, I very would love if anyone has reactions or would like to, give me any feedback. Feel free to reach out either on LinkedIn. You should be able to just find me by searching for Spencer in Cockroach Labs.
Well, thank you again. It's been an absolute pleasure speaking with you. Thank you for sharing everything that you've shared. That's it for today's webinar. Thank you, everyone, for joining us. We'll send you the slides probably tomorrow, but otherwise, fill in the survey if you get time, and we'll see you at the next one. Thanks again.